Hello, this is Dr. Christy Patton Lukes, and this is exam 3 for Thermo 1, and this is our solution for that exam. So for questions 1 through 3, let's go through those. So the natural variables of the Helmholtz energy function was the question. And for that, what you want to do is look at the fundamental relation for A, which is dA is minus SDT plus minus, we can fix this, minus PdV. And if I use that, then what this is saying is that this is equivalent to how A changes with T holding constant V dt, and how A changes with V at constant T dV. In other words, it's telling me that A is a function of the variables T and V in this natural fundamental relation form. And so therefore, the answer is V and T. Now in the second question, we have this curve here, and we have enthalpy along this axis, we have specific entropy along this axis, and we have a curve marked out that is indicated that it is a constant pressure or an isobar. And so the slope of this line is how H changes with S along this constant pressure path. And so the correct answer in this case would be B. To do question 3, we need to look at the equations for nozzles. Now they were on the formula sheet that was provided. So the formulas I've written here in blue, and in this case I have U inlet is greater than C. So that means that the Mach number is going to be greater than 1. So this is supersonic flow. And in the nozzle shown here, what I have is that the area, as X increases, the area decreases, so this will be negative. And so if I look at this, if I look at dP dx, I have a group here that is all positive. 1 over 1 minus m squared, well, m is greater than 1, so that is going to be something negative. And dA dx is negative, so I have a positive times a negative, which means that I will have a positive answer. So P exit will be greater than P inlet. If I look at the velocity, I have a negative sign, U over A, those will be positive. 1 over 1 minus m squared, that's going to be negative, and dA dx is negative, so I have 3 negatives, so this will be negative. And so we end up with U at the exit is less than U at the inlet. So U at the exit is less than U at the inlet is one of these two. And P at the exit is more than P at the inlet, so it's this one, and so this is the correct answer.